Hi, welcome to section 2.9 linear equations with decimals. In this part, we're going to learn how to clear decimals, so meaning changing from decimal to whole numbers. And then once you convert to whole numbers, we can solve like any regular equations with whole numbers. So let me go with some basic on converting decimals into whole numbers. So as I mentioned before about converting decimals to whole numbers, I'm mainly talking about how we clear decimals by moving the decimal points left and right. So in order to move the decimal point, you're essentially multiplying the number or the equation by a specific number to move the decimal point how many places. So let's take a closer look at what I'm saying. So here we have 2.5164. When I multiply by 10, we get 25.164. So here, when you multiply by 10, we move the decimal between the 2 and the 5 to now between the 1 and the 5. Essentially, we move the decimal one place to the right. If I use the same number, 2.5164, when I multiply by 100, now the decimal is between 1 and 6. Essentially, we move the decimal two places to the right. If we use the same number and multiply by 10,000, so it went from 2.5164 to 25,164. So essentially, we move the decimal point 4 times to the right. So when we multiply by either 10, 100, or 10,000, you'll be moving the decimal point to the right. And if you look closely, if we have 1 0, we move it 1 time to the right, 2 zeros, 2 times to the right, 4 zeros, 4 times to the right. Now, let's take a look at the example on the right. So here I'm multiplying by 1 over 10, 1,000, and 1 and 100,000. So essentially, we're going to be dividing. So, starting with 3.71, even though it says multiply by 1 over 10, you're essentially dividing by 10. So when we divide it by 10, we get 0.371. So what happened was we moved the decimal point one place to the left. Now, using the pattern I explained earlier, if we were to divide 3.71 by 1,000, so that's 3 zeros, so we essentially move the decimal point 3 times to the left. Now, the same number 3.71, if we were to divide by 100,000, so that's 50, so we essentially move the decimal point 5 times to the left. As you can see here, we got 0.0000371. Now, I'm just explaining on how the decimal point moves. Is simply either multiplied by a specific number, 10, 100, 10,000, 100,000, and so on, or divided by 10, 1,000, 100,000, 10,000, any numbers depending on which number you're looking for. So if anybody asks you why the decimal point moves, it's simply because we multiply by these specific numbers or divide by these specific numbers. But in this section, I'm not going to require that you write out these multiplication or these division. I'm just explaining that this is how the decimal point are moved. So let's take a look at our first example. We have 3.24 plus 5z equal negative 4.7z plus 1. So we do need to move the decimal and then make sure that all of them are whole numbers. So I'm going to first identify the decimal point. Now the first one we see clearly in 3.24 and the second one 4.7. Now for the 5 and the 1, they didn't have it initially, but I marked a green decimal point to show you that they are there, they're just invisible. So I repeat, the decimal point on the 5 and the 1, they are there, they're just simply invisible. Now what's the reason for this? Is that when you move the decimal, you have to move it for all the numbers by the same amount. So I repeat, you have to move the decimal point on all the numbers, meaning all the parts, by the same amount. So if we were to move by 1 decimal to the right, I want to simply move the decimal point on all parts to the right 1 time. So I'm going to show you what happened when we move it by 1 time. So it went from 3.24 to 32.4. The 5 went from 5 to 50. The 4.7 became 47, and the 1 became 10. Now the issue is we still have a decimal in the 32.4. It's not a whole number. Now in here, the 50, the 47, and the 10, they do have the decimal at the very end, but it's still okay because they're still technically whole numbers. Right here, 32.4, it still have the decimal in between. We kind of want the decimal at the end of the 4. So let's reevaluate this example. So again, we're back to the original. 3.24 plus 5 equal negative 4.7z plus 1. So when you're determined on how many times you have to move the decimal, always look at the one that has the most decimal place. So in this case, 3.24, it has 2 decimal places. So what we're going to do is we're going to move the decimal point in each part, and we're going to move it 2 times to the right. So it went from 3.24 to 324. The 5 became 500. The 4.7 became 470. And the 1 became 100. And here I highlighted the zeros in green to show you that from 5, it moved the decimal 2 times to the right. So those empty spaces are filled in with zeros. The 4.7, again, it moved 2 times to the right, so it had 1 empty space. You fill that in with a 0. And then the 1, it moved 2 times to the right, so those empty spaces you fill in with a 0. I do recommend that on paper, when you draw the arrows to visually show that you're moving the decimal to the left or to the right, make sure that those empty spaces you can clearly see, and to clearly fill in with zeros correctly. I had in the past where some did it too many times or did it too fast. So when they fill in the zeros, they either fill in too few or too many. So I repeat, when they were rushing, filling in the empty spaces with 0, there were too few or too many zeros, which lead to having wrong numbers, therefore wrong answer. So make sure that when you move in the decimal with the arrows by pencil, that you do it carefully, correctly. Once you determine your empty spaces, you fill in the right amount. Alright, so we finished moving the decimal and we got whole numbers. So 324, I highlighted in blue because it went from 3.24 to 324. The 5, the 1 became 100, 500. And then the 4.7 became 470. So those I highlighted in green because those are mostly the ones that we're focused on adding the zeros. Whereas the one in blue, the 3.24, just simply became 324. So we're going to use these numbers to solve for z. So the first thing we want to do is we want to have the z on the left side. Now, I'm just going to do it this one way. It's okay if you solve and have the z on the right side of the equal sign. It doesn't matter to me. As long as you add, subtract, and balance the equation correctly, you should get the same answer as mine. So, since I want the z on the left side of the equal sign, I want to cancel out negative 470z. And I'm going to balance it out by doing the same thing on the left side. So add 470z on the right and on the left side of the equal sign. So when I do that, the z will cancel on the right side of the equal sign, and then on the left I'm going to get 970z. I'm going to bring down 324 and the 100. Now since I have the z on the left side of the equal sign, I need all my numbers on the right. So I need to cancel out 324 from the left side. So to balance the equation, I'm going to subtract 324 to both sides of the equal sign. So minus 324 on the left and minus 324 on the right. So that's going to cancel out 324 on the left side. And then on the right side, 100 minus 324, that will be negative 100, negative 224. So excuse me. So I repeat, negative 224 on the right side, and I brought down 970z. Now to solve for z, we're going to have to divide both sides by the number that's in front of z. So I'm going to divide both sides by 970. So that's going to get z by itself on the left side. So we're going to have at the moment z equal negative 224 divided by 970. So I repeat, we have z equals to negative 224 over or divided by 970. Now, whenever you have a fraction, you have to check it if you can simplify. So, in my experience when working with big numbers, I don't know all the multiplication right away. However, I do know that 224 and 970, they're both even numbers. So I'm going to divide the numerator and the denominator by 2. So when I do that, my new fraction will be negative 112 over 485. So I check one more time if I can simplify. Now I usually look at the number that ends with 5. So 485, I usually check that because usually are divisible by 5. And when I divide this by 5, I get 97, which is a prime number. So 5 and 97 do not go into 112. But sometimes it couldn't hurt to check for 112 what numbers that can go into that and see if there's a common number that you can use to divide 485. In this case, when I check 485, two numbers can only go into it, which is 5 and 97, which both of them are prime numbers, meaning that they couldn't go into 112, so there is nothing in common between the numerator and the denominator. So my final answer will be z equal negative 112 over 485. Now, as I stated in the previous part of 2.9, if you have the numerator bigger than the denominator, which is an improper fraction, leave it like that unless it was specified or asked to finalize with mixed number. So I repeat, if your numerator is bigger than the denominator, which means it's an improper fraction, leave it as your answer unless it was specified or asked to finalize with a mixed number fraction.